Not yet. Talk. It's doing its warm-up thing. Alrighty, it's warmed up. So first slide, drop-ins. I've stuck an extra drop-in in because we're in here while there's a drop-in going on. 1 till 2 o'clock today's. So on Mondays, I won't bother week 8 because it's a mid-semester exam on. People rarely go from mid-semester exam straight to a clinic. But apart from that, it'll just be a regular thing. 1 till 2's on Monday. So straight after lecture, if you want some drop-in time, it's a new one. That's on Blackboard as well. What else we got? Resource sheets. Just a reminder, yeah, we start quizzes this week. So resource sheets for every assessment task. That's all with the reminders. Any major queries at the moment? All good? Okay, so this lecture starts, well, pretty much continues on from the last one. Okay, the last one was simple interest, find, calculator use, and ratio. We start with a bit more ratio, but it's in a different form. Or it starts in a different form anyway. And it's scale measurement. Probably our most common way that we apply our ratio. We look at a map and the map says I'm a scale of 1 to 100 or something, or a diagram might be scale of 10 to 1. It's just telling you how big real life is compared to your picture. So, it's used when creating a large or reduced size reproduction, photocopy of whatever. In the format of a scale, until now, the left to right, who cares? Whatever words you say, if it was pink to blue and it was 5 to 1, okay. But I could always swap the sides. In scale measurement, the scale is always, the scaled item is on the left and the actual item is on the right. So the left represents the fake size, the toy, the picture, the whatever. The number on the right represents whatever the thing is in real life. I like to remember that thinking SCA. The SCA from scale, I've got S and then a colon, starts with C and then an A for actual. So just thinking SCA, the first 3 letters of scale reminds me, okay, the scale thing goes on the left, colon, then the actual measurement goes on the right. And this is something which you just may want to, because units come in here, scale measurement maps and all that, of course we're going to do a lot of kilometres, metres, centimetres, millimetres. And I just think this graphic might be handy to have on the resource sheet, just as a reminder. We don't go all through last semester stuff, we just go, okay, if you know, if you've got something in kilometres and you times it by 1,000, you've converted to metres. So 5 kilometres times 1,000 is 5,000 metres. If you've got 5 metres times by 100, it's 500 centimetres. If you've got 5 centimetres times by 10, it gives you 50 millimetres. That's maybe just a handy little reminder. Kilometres to metres, metres to centimetres, centimetres to millimetres, and of course, backwards. If you're trying to convert millimetres to centimetres, divide by 10. Centimetres to metres, divide by 100. Metres to kilometres, divide by 1,000. Handy little resource sheet thing, quite possibly. I think I stuck it in the notes this year. Yeah. Okay, so let's look at this. What are we talking about? Finding the scale. So here's a map, and a distance of 40 metres, not much. The distance of 40 metres is represented by 1 centimetre. So in other words, I can call a scale on the map. 1 centimetre represents 40 metres. Nothing wrong with reporting it like that. But let's find the scale as a ratio in its simplest form. Firstly, I'm saying SCA, scale, colon, actual. It's going to keep doing that. They haven't fixed the thing yet. So the scale thing goes on the left, the actual thing goes on the right. Distance of 40 metres, that's real life. So that's actual. The 40 metres goes here, and the 1 centimetre is a scaled item that's on the map. So 1 centimetre goes here. So there I've written as a ratio, and now we just flip back to last week. If I want that, and there's nothing wrong with that, but if I get asked for that in the simplest form, I don't want units, and I want the smallest numbers possible. And I don't want fractions, but there's none there. My gut instinct is always to convert to the small units, leave the 1 centimetre alone and think, how do I convert 40 metres into centimetres? And the thing on the page before was telling metres to centimetres is just times 100. So 40 times 100 centimetres, fine. It's 1 centimetre to 40 100 centimetres. So that's me. I've gotten rid of the... I can get rid of the units now. If they're the same, I don't need to report them anywhere. One length is equivalent to 40,000 of the same lengths, whatever it is. Then, can I simplify it? No, it's just 1 to 4,000. I'm done. Okay? So finding the scale in its simplest form, it's really just last week. Now we've got another one, scale to actual. We're talking about a large diagram of a beetle. So the numbers are going to be the other way around. That one then was a big distance being represented by small. Now it's a small beetle being represented by a big diagram. But it's still the same direction. Scale to actual. Blame the Knights for the voice, by the way. It's not my fault. I'm not crook. Just very, very happy. 60 centimetres on the diagram, actual 15 millimetres. So I'll put my 15 millimetres there and my 60 centimetres there. Okay, I've put the things in the right order, left to right. I'm going to convert to the smaller units, which is millimetres, so I'll leave 15 millimetres alone, but that my little resource sheet thing said centimetres times 10 will give you millimetres. So 60 centimetres is just 600 millimetres to 15 millimetres. Units can go away. 600 to 15, I could do it on the calc. I could go straight to what's 600 divided by 15 and look at the answer as a fraction. Or if manually I said, look, I'll divide u by 3 and I'll divide u by 3, that'll give me that. If I divide u by 5 and say how many 5s are in u, it doesn't matter, we've got the calc. But I'll get down to 40 to 1. Okay? Initially, if I accidentally misread the units, it would have been 4 to 1, a 60 and a 15, but yeah, just check the units. Okay, so hopefully not too much of a stretch, that stuff. But let's just look at this left-right thing. If a 1 centimetre long insect is drawn 20 centimetres long in a diagram, the scale of the diagram is, clearly it's 50-50. All these ratios are 50-50. When you're going to do this, you're either going to times by 20 or divide by 20. And normally it's obvious, okay? But just reading it that way. Just pick on the 1 centimetre or the diagram, whichever. Pick on the 1 centimetre. Do you reckon it's A or B? Because the 1 centimetre long insect is the actual insect. The actual thing goes on the right. So the 1, that's the actual thing. The diagram is a scaled thing. So if I'm putting scaled then actual, it's the 20 to 1. Okay? And I just stuck in another slide to see if this helps. So if you've got a scale to actual, if it's written like a small number to a big number, then the scaled thing is small compared to real life. So the 1 goes on the left for big maps and stuff, maps that are representing the Earth or whatever. But if I've actually enlarged a small thing, notice how on the left the scale thing is bigger than the actual thing. Okay, so just looking at it, you can go, is the number on the left bigger or smaller compared to the other? If it's smaller, I've made real life smaller. If it's bigger, I've made real life bigger. I've enlarged it. So you can see this scale of map of Australia. The 1's definitely on the left. Huge scale, 1 to 10 million. So it doesn't matter what units you want to call it. That means for every 1 centimetre on the map, it represents 10 million centimetres in real life. Or 1 kilometre on the map. I probably don't have a map that's 1 kilometre, but that would represent 10 million kilometres. So I'm going to start off the same way as normal. It's always scaled to actual. So it tells me the ratio in simplest form as that, 1 to 10 million. Now it's asking me about a distance on the map that's 40 centimetres. On the map's the scaled item, not an actual. So the 40 goes there. Now I can see that this basically means 1 centimetre represents that many centimetres, so it's like the opposite. I want to bring centimetres in because I want to use it. So what does 40 centimetres relate to? Well, same as last week. If I know what 1 does, I'll just times it by 40. All this is saying if 1 centimetre represents 10 million centimetres, 40 centimetres represents 40 times 10 million. Well, I know it looks a bit heavy in zeros. We probably won't stick to centimetres. We'll convert soon. But that 10 million times 40, well, it becomes 40 million and then adds another zero. So it becomes 400 million. Again, it can go to the calc. But all I did was times by 4 and add another zero. That's 40. So that's my answer in centimetres. But if we look at multiple choice, the answer's not going to be given as 400 million centimetres. Let's start converting it. 400 million centimetres, if I take 2 zeros off, then it becomes that many metres. Okay, so all I did, because I know that every 100 centimetres is a metre, now let's take off 3 zeros to convert to kilometres. So that's still like using that little cheat sheet we got. We said divide by 100 gets you from centimetres to metres, divide by 1,000 gets you from metres to kilometres. So the distance from Perth to Sydney is 4,000 kilometres. 40 centimetres represented 4,000 k's. And again, if you went the wrong direction, you're going to know pretty soon you're screwed up. If you're trying to divide 1 centimetre by 10 million or 40 centimetres by 10 million, you know it's bigger. So this one, the flea in this diagram is a scaled length of 48 millimetres. Given that the scale is 40 to 1, what's the length of the actual flea? So they've given us, we've got scale to actual, and it says the scaled length is 48 millimetres at this scale of 40 to 1. So that's my setup. I know it's 40 scale to 1 actual. I know 48 millimetres got to go to something. Note that in the notes, the way I've done it there is a hard way, really. Previously, we used to just say, what did I do to that to get to there? 40 times what gives 48? We'd go to the calculator and say 48 divided by 40 is 1.2 and go ahead that way. But it's not as nice to see. This semester we've said, look, I think you can handle it. You can go that way if you want, or you can go that way. That's what we said last week. And what's easier to me? I'd rather do this horizontal one. I'll say whatever you've got on the left, divide it by 40 gives you what's on the right. Whatever you've got on the left here is 48. Divide by 40 will give me the answer. That's all I need. All this ratio is telling me is the flea is smaller. The flea is not a 48 millimetre flea. It's 40 times smaller. Just get your 48, divide by 40. That tells you the same thing. So if I'm dividing by 40 there, I divide by 40 there, the calculator tells me it's 1.2, and I'm done. Again, I had a 50-50 shot. If we start to understand that 40 to 1 means the scaled thing is bigger than the actual thing, then that'll tell me the flea is small. It's not 40 times 48 millimetres. It's 48 divided by 40. Note the course reader used the other method. They both work. If that flea is 14 centimetres long in the picture at a ratio of 1 to 12, how long is the actual flea? Well, it's 1 to 12. We know that's scaled, and we know that's actual. So that's telling us the actual thing is 12 times bigger than the scaled thing. So if in that picture is 14 centimetres long, it's telling me actual life is 12 times bigger. And also, hopefully, you can see it. This joke probably is too olden day now. Does anyone know who Flea is? Ah, it's still there. Okay. Red Hot Chili Peppers bass player. Calls himself Flea. Anyway, not a real flea. No, thanks, Silver. Okay, so clearly he's 14 times bigger. That's still a genuine question, 12 times bigger. So we just have to know which direction. The picture helps. Okay, it's a human. But it's a times 12. 14 by 12. Oh, we've got our calcs now anyway. I'm not even bothered to do it manually. So we get up to 168 centimetres. And again, the conversion, he's slept around. Bring up virus protection. That didn't work. 1 to 12 scale model of a car. Okay, the car's 25 centimetres long. This is the model. Again, that's scaled. Clearly, that's the scaled thing. How long is a full-size car? Scale to actual. The scale model of a car is 25 centimetres long. So, it goes on this side. Again, I've got myself 50-50. I'm timesing by 12 or I'm dividing by 12. And obviously, actual life is 12 times bigger than the scaled. So all I've got to do is go over here, do 12 25s, and give me naught, okay, it gives me 300 centimetres. 12 lots of them are 25, or 3 metres. Either way, I've answered my question. So hopefully this scale to actual isn't much of an extension from last week's ratio. And we can get some common sense out of it, bit of applied. Another one, okay, clearly it's the other direction. Still the same old 50-50. We've just got to deal with some decimals here. Insect under a microscope is enlarged by a scale of 50 to 1 to be shown as 10 centimetres long on a computer screen. How long is the actual insect? Well, scale to actual is 50. The actual thing is 50 times smaller than what you're seeing. What you're seeing is the computer screen is the scaled measurement here, which is 10 centimetres. So 10 centimetres to something, well, you could look at it this way and say this number divided by 5 gives that. So the answer is 1/5 or 0.2. Or you could say left divided by 50 gives right. 100 divided by 50 is also 1/5 or 0.2. Doesn't matter which way I go. I'll just stick with this way. Left divided by 50 is right, and 10 on a 50 becomes a 1 on a 5, which is 0.2 centimetres. Okay, how long is the actual insect? 0.2 centimetres. If that's not in multiple choice, maybe it's 2 millimetres, because centimetres times 10 gives millimetres. But again, it was 50-50 and a clear way to go. Okay, scale measurement. So, this is where we move from our ratio stuff and go into a bit more extended use of it, which is proportionality. And again, it's applied. We've got some real life situations that will make common sense, stuff you can picture and go, yeah, okay, I get what you're saying. So we dealt with the same units in a linear relationship. Linear relationship, that'll make more sense soon when we start plotting, but it's like linear relationship means when this gets bigger and this gets bigger, if I double this, this will double, if I triple this, this will triple. If I plotted them, I get a straight line, not a curve. But we'll come to that, that will become clearer. So, we're going to deal with 3 types of proportionality. Like I might say, the understanding of mass is proportional to how much work you do on it. Just all that statement means, the more work you do on it, the more you'll understand it. Okay, that's proportional. That's like close to linear proportionality. So when one goes up, the other goes up. Fine. The number of bricks I have is proportional to the weight of them. Of course it is. For every brick I have, it weighs this. If I have 10 bricks, the weight goes up 10. If I have 20 bricks, so on. There'll be just proportional ones which are not linear. Not every relationship will be some straight line thing. Some relationships might be a curve, might be that way. It might do all sorts of things, that it's just not a straight line relationship. The growth of a tree. If I've got the height of a tree versus the time since it's been planted, trees grow really rapidly at the beginning, but they don't keep growing at that rate. Trees do that. And there's a maximum sort of height you normally get from an old tree. Okay? So it's still proportional. Of course the height's proportional to how long the seed was planted, how long ago it was, but just not a straight line. Okay? And the third type is inversely proportional. That when one goes up, the other goes down. Like the number of people in this room versus the oxygen concentration. We're all here sucking out the oxygen. If we turned off this sounds a bit morbid, but if we sticky taped ourselves in here and duct taped all the doors, the number of people we had in here, well, the oxygen, the more people we had, the less oxygen we would have, because it'll all be losing it more. So there's some things which are going to be inversely proportional. One goes up, one goes down. So we'll look at all 3. But first we need to introduce the number plane. You weren't expected to know, when I'm doing that and that, oh, what's he doing? Well, we need to introduce the number plane. And hopefully I think it comes in year 7 or 8 that we first meet the number plane and start saying x comma y. As in I can represent any point on this plane by 2 numbers to tell me where we are. And the plane is always, it's like, we've used the number line before. We were talking negatives, 0, 1, 2, and when we'd say, well, if I had what's 2 minus 3, I would have started at 2 and gone back 3. That was using the number line. This is just 2 number lines. It's like all we were doing then was using a number line which is called x. Now we're saying there's a height as well, okay? There's a whole number plane. This is x and vertical is y. So x always represents horizontal moves and y are vertical. So the origin is just called 0,0, as in the x coordinate, how far is it away from the middle? X-wise, nothing away from the middle. How far is it away from the middle y-wise? Nothing. It's just given the name the origin because everything's measured from there. That's the point 2, 3. Now it's be easier to mess it up with 3, 2 or something. There's definitely no negatives because the negatives are that side and that side. It's all positives. But the x comes first. So how do I label a point? I say, how far have I gone horizontally? I've gone 2 horizontally. How far have I gone vertically? 3. So it's not 3, 2, it's 2, 3. Okay. There, -1, -2. Horizontally, then vertically. Horizontally, if I start at the origin horizontally, I went to -1, and then I went down to -2. It's a -1, -2. 1.5 minus 2.5, they don't have to be whole numbers. It can be √2, which is 1.41, whatever. Doesn't matter, they still make sense. That 1.5, okay, I've gone to about this 1.5 point, and then I've gone down to -2.5, which must be halfway there. So a positive 1.5 and negative 2.5. That's how we plot our points. So we're not going to be bothering with the negatives because this is an applied course, okay? But that's the overall number plane. So what's that point? What could you describe that one as? Horizontal first, then vertical? And it's not. That's the trap answer. Yeah, Trevor was tempting. B. Yep. So we've gone horizontally to -3, vertically to 2. Perfect. As long as you're x then y, it's all good. And remember, it's just in alphabetical order. X does come before y. The first one tells you the x distance, then the y. Okay. Following point. When it's on the axis, it can be a pain to think, but it's exactly the same logic. Picture yourself at the origin in the middle. How far did you go horizontally, then how far did you go vertically? C. Yep, you didn't go anywhere horizontally. So if I started here, horizontally I moved nowhere. Vertically I moved 3. Okay? So if you're on the line, we can still label it. 0 horizontally, 3 vertically. Cool. So that was just the background to it, and like I said, now we're just going to deal on the positives. As long as we know when we're plotting points, that's how we got there. So we'll start with the most basic one, which is directly proportional, the straight line relationship. Now, two variables are said to be directly proportional if one is increased by some multiple, maybe times 2. The other one increased by the same multiple, times 2. Okay. It's always a linear function, meaning straight line passing through the origin. So if we look at something like this, y equals 2x, that's a function which says my y values are going to be 2 times my x value. So if my x value is 0, my y value is 0. And I can plot that point. That's the point x, y, 0, 0, which is right there, red dot at the origin. Now if x equals 1, and I sub that in, y equals 2 times, now it's a 1. 2 ones are 2. It's the point 1, 2, which goes 1, 2 on the thing. So we're plotting on the number plane. 2 times 2 is 4, which is 2, 4, which is plotted. 3 times 2 is 6. And you see, once I plot them, that's why we call it linear, straight line. Not like the height of the tree or whatever, it's linear. And we say, except for 0, 0, the ratio of the two variables remains constant. Like, what was the ratio here? It said, except for this, there's no ratio in 0, 0. 1, 2, 2, 4, 3, 6, 4, 8. They're all the same ratio. 1 to 2, 2 to 4, 3 to 6, 4 to 8. So that's directly proportional. Straight line through the origin. We said that. So, catering costs versus the number of guests. Okay, I'm being pretty rough here. I'm no caterer. Pretend you booked a hall and all they said was, we're just going to charge you by how many guests you got. So $50 per guest, that's what you've got to pay. Directly proportional. Every time a guest comes along, the cost goes up $50. Straight line. Distance travelled versus time. If you're travelling at a constant speed, that'll happen. Okay, if you're just travelling at 60 k's per hour, for every hour I travel an hour, maybe that's time, 1 hour, I travelled 60 k's. After 2 hours, I was at 120. After 3 hours, I was at 180. That's constant speed, so directly proportional. Litres of paint, area to be painted, directly proportional. More area, more paint, by the exact same ratio. Okay. So we need to get a formula going with this. Y equals kx. So that formula itself, I said before that when one doubles, the other will double. Maybe when one triples, the other will triple. That number we're talking about is the constant of proportionality. In other words, if everything was doubling, it's a 2. That's the one we're just looking at. If y equals 2x, it means x just got times by 2. So, if we look at this example, can we see what's happened here? What did x get times by to become y? 1.5. 0 times 1.5 is still 0. 0 doesn't help us find the answer. 1 times what gives 1.5? 1.5. 2 times 1.5 gives 3. 3 times 1.5, yep, k equals 1.5. If you can see the relationship here is the same as that, then really that's as far as we're going in this initial bit. All the y values are equal to 1.5 times their x's. Yep, and the constant proportionality is just, it's nicknamed k, as in we tell you that, hang on, this situation, all the x's times some k gives y. We say, what's the k? And we just find out that way. I could have picked a point and subbed it in if I wanted. As long as you're not subbing the noughts in, if I had just subbed in, that tells me x equals 2 and y equals 3. The formula said y equals kx. Well, if I just sub that stuff in, the y is a 3 equals k by 2, then I do a little bit of algebra which says if I want that k by myself, I better divide both sides by 2. 3 on 2 equals k. 3 on 2 is the same as 1.5, is the same as 1.5. So if it doesn't jump out of the table at you, you can just sub stuff in. That's what's the k. Same as on the next example. We're being told that y is equal to kx, and we're just being asked, find that k. Well, I could pick a point, except for the zeros, or just observe it. X times something gives y. 3's jumping out, but what's the real answer? Yeah, 0.3 repeater, a third, okay? It'd be easy to say k equals 3 because it's something very 3-ish going on. But pick the order. X times a number gives y. 3 times what gives 1? 3 times a third gives 1. I don't say 3 divided by 3, it's 3 times something. I had to quote a third. Again, by observation, if that sucks, then just go to the formula. Pick, that'll do. If they told us y equals kx, then gave us a list of answers, well, let's just chuck in a y equals 1 equals k times a 3. That's just chucking in a set of points. X equals 3, y equals 1. If I want that k by itself, I'd better divide both sides by 3. Yep, we're done. So subbing in one point that's not the zeros will answer it for us. So what's the coefficient of proportionality for the following linear data? Again, we're told y equals kx. It'll complex up later, but that's it. Pick any of these 3 points, or just C makes sense. Y equals a 7th times x. Does 3 times a 7th give y? So we've got to make sure we get our order right. Yeah, exactly, it's back to the 7. So you can see that trap's going to come. 7's going to be there, a 7th is going to be there. It's 70, but x times k, 6 times, yeah, it's got to be 7. It wasn't the upside down one. X times what gives y? X times 7 gives y. So don't overthink it. Cool. That one. It's exactly the same. It's always x times what gives y. It's A or C. I can see the 5 happening. It is C this time. 10 gets times by a 5th, it becomes 2, not 5. Okay, and again, you just sub a point in if you want. Good. Other ways that it's worded, I'm going to stick to fairly simple wording because this isn't a literacies course. Obviously we've got more words this semester, but we're not going to get all fancy with it. But just the way to say things are directly proportional. You can say that they are in direct variation, or they vary directly. Again, the direct is saying through the origin, and direct variation is always linear. They vary proportionally to each other. It's in proportion to y. So it won't always say the word direct. If it just says proportion, it means directly proportional, unless you've got another word included. We'll soon see that there are other ways. Proportional to its square, okay? If you chucked in that word to its square, I know something else has happened. But just keep it simple. If there's no word like square or square root or cubed, it's just a straight up y equals kx. Just straight, normal. So, an applied example. And this is exactly the sort of wordiness we'll have, okay? An exact sort of question for us. The distance d a car travels varies directly with the time. Instantly, that's saying nothing, didn't say inverse, which we'll come to later, didn't say with its square, it just said varies directly. Y equals kx, straight line. Varies directly with the time the car is in motion. So instantly I know it's something like that, distance versus time. Not that we're being asked to sketch it. If a car travels 120 k's in 2 hours, find an equation relating distance and time. Without any of this topic, hopefully you can think that if it travels 120 k's in 2 hours and the car is just a constant speed, if I'm travelling 120 k's in 2 hours, that's 60 k's per hour. And that is it. We'll find an equation relating the distance and time, 60 k's per hour is the speed. Well, let's look at the way we lay it out. D equals kt. I didn't write y equals kx just because it was a d and a t, not a y and an x. It's just an applied example. If I had done it the other way, it still would have worked. If I had written t equals kd, still the same thing. Okay? It doesn't matter which way you go with it. If I wrote d equals kt, I might get a k of 10. If I wrote it the other way, my k might be a tenth. It's still going to work. But out of habit, whatever one was said first, you can be my y. Whatever one's second, you can be my x. So d equals kt. There is some value of k that when I times my t by it, you'll find out the distance. Let's chuck in some numbers. D equals 120 when t equals 2. Okay? D equals 120 when t equals 2. I can chuck them into that formula. Replace the d with the 120 and the t with the 2. And like before, I don't bother writing the units there, that just gets messy. And it doesn't matter what the units are in, don't convert. Kilometres there and hours there, that'll do. All it means is the k we find will deal with distances in kilometres and time in hours. As long as we're consistent, it's all good. My little bit of algebra here is divide both sides by 2 to get k by itself. So k equals 60. So what's my formula? Well, it says find an equation related distance and time. I knew that d was equal to kt. I just didn't know what k was. I know what k was. Just rewrite it. So that equation tells me if you give me any time in hours, I'll spit out a distance in kilometres. And it makes sense because the speed was 60 k's per hour. So if I sub in, if it then says, well, what's my distance after 4 hours, that's just saying t equals 4. If it said, what's my distance after 30 minutes, I wouldn't just chuck 30 in, because that formula was made using kilometres and hours. So all that means is, you give me hours, I'll chuck out kilometres. Just, once again, whatever the units are you use to find the k is your units now for good. Let's check another one. The height of Lucia's sculptures varies directly with their width. Okay, varies directly, it's just one of these y equals kx things. As soon as I see it, there's nothing fancy going on. But they're not y's and x's, they're heights and widths. Okay, height equals sum k times width. H equals kw, that'll it? There exists some k that makes that true. The height is equal to some number times its width. It must give me some numbers I can chuck in, and it has. It says if a 10.5 centimetre high sculpture has a width of 3 centimetres, that's all the info I need. I just make sure I put in the right spot. H is 10.5. Yep. 10.5 high. H is 10.5. Equals K. I don't know what K is yet. Stop it. Times W, width of 3. So I've used an H of that, a width of that, chucked it in. I'll divide both sides by 3 to get that k by itself, to get rid of the times 3, gives me k equals 10.5 divided by 3. In other words, k equals 3.5. So, what was my equation? It's just combining that and the k I found. Height equals k is 3.5. That's what we're after. The height of these statues is 3.5 times their width. And again, well, yeah, the height was 10.5. That was 3.5 times the width. It's always going to be 3.5 times the width. So, done. The next bit's predictably will be, okay, use the formula. Whatever you found that equation, use it. First says the height of a sculpture width 4 centimetres. Well, if we found out that the height was equal to 3.5 times the width, then if the width is 4 centimetres, the height is 3.5 times it. That's all. It's pure substitution. 3.5 times the width of 4, which is 14. And the units were centimetres. The units in this whole question were centimetres. We chuck centimetres in, we're getting centimetres out. More centimetres. The width of a 21 centimetre height sculpture. Well, the formula is h equals 3.5 w. But don't chuck 21 into the w, because it's a 21 centimetre height. It's telling us the height is 21, what's the width? The width is smaller. These things are 3.5 times taller than they are wide. So the height gets replaced with a 21. That's my formula. And I've got to remember that that means 3.5 times w, so how do I get the w by itself? Better divide both sides by 3.5. 21 on 3.5 equals w, and we've got the calc, so w equals 21 on 3.5, which is what? 3.6. 6. So width equals 6. All of our units were centimetres. So does that make sense? 6 times 3.5 is 21. Yeah. 6 centimetre height would make a 21 centimetre high thing. This question we've just done, even when we talk about squared and cubed and inverse, certain things that are coming, all the steps are the same, okay? Boringly so. Okay, yeah, words, but before even looking at it, it's going to give you a formula by, well, we've only done directly so far. So it's going to let me know something equals k times something. It's going to give me some numbers I can chuck in, and then it'll probably ask me a question. Okay. Are there follow-up questions? No, it doesn't ask a question, it just wants. During a period of constant rain, the time and depth of rain in a rain gauge were measured. Find an equation for the relationship between time and depth if after 2.5 hours there was 25 mils of rain in the rain gauge. So yeah, horribly wordy. But the fact that it says the time that it was constant rain, these things are directly proportional. There was no change, it was just constant. Just rose constantly. No squared, nothing else. Just a constant proportionality. Now, we're talking about what? We're talking about the time and depth. All right, let's time be t and d be depth. That's good enough. We know we want letters. I don't want to use y and x. It gets confusing. I know that I can initially say it's clearly one of these, y equals kx, but I don't want y and x. I want t equals kd. Time equals k times depth. So I want to find a formula that tells me how long do you reckon it's been raining, or what's t if I give you d. I didn't mean to look at you then. That was bad timing. I'm not giving you D. What have we got? A depth, 2.5, and... Oh, sorry, depth isn't 2.5. Time is 2.5. Depth is 25. So it can be easy going around the wrong way. Again, the units, I don't care. Hours and millimetres, yep, fine. Whatever you've given me is what I'm going to use it for. I'm not going to convert. The time is 2.5, 2.5 equals k times a depth of 25. All right, sweet. How do I get that k by itself? Divide both sides by 25. Go away. 2.5 divided by 25 equals k, because I divided both sides by 25. That gives me 0.1. Therefore, my formula is just combine the two. Oh, that one. Instead of t equals kd, t equals 0.1d. That's the formula. And so now if someone asked me, well, what if there was 100 millimetres in there? I'd say, well, 0.1 times 100 is 10. That'll take 10 hours. Okay? We form an equation, we can use that over and over. All right. This is still going to have repetition. We're going non-linear, but let's look. It's still going to happen the same. We don't have to graph this stuff. We don't have to know whether the curve's going steep or shallow or anything. But just maybe of some interest, if the question says, look, the depth of the rain gauge is increasing as the square of time. As soon as it says as the square of, it brings in a squared. That's y varying as a square of x. Okay? And it looks like half a parabola, but we don't have to know that. Y varies as the cube of x. Again, that's the picture. It's like a steep parabola. But all we have to know is if it says cube of x, x gets cubed. Y varies as the square root of x. Again, don't have to know it looks like that. But you have to know if the question says square root of x, square root your x, not your y. Okay? Still hopefully straightforward. Here's one that's not a word problem, okay? It's not an applied one, it's just someone's telling us it's not just x times something equals y, it's this. X squared times something equals y. And it's asking us to fill in some blanks. Determine the value of k, and then complete the table of values for the following non-linear functions. Well, I've only got one set of data that's complete, x and y. There's no other ones. I can't chuck x of 0 and y of 400 in. They don't go together. There's only one set of data I can possibly use to chuck into this equation. Let's chuck them in. Just make sure I get them around the right way. The y is a 16 equals k times, and the x is a squared. So before I wrote the squared, clearly on the old ones, my answer was going to be k equals 8. But no, it said squared. 16 equals k by 2 squared. Order of operations says do that 2 squared. 16 equals k by 4. Algebra says you want to get rid of that times 4, better divide by 4. 16 divided by 4 is a 4 equals k. My actual formula, by using this data, isn't just y equals kx squared, it's y equals 4x squared. So as the question asked, it said find the value of k. I found it. So all of the y values are 4 times the x squared. Let's check that again. When x is 2, 2 squared is 4, 4 4s are 16. Yep, that works. What if the x was 0 and we chuck that? What's 4 times 0 squared? 0. What's 4 times 1 squared? 1 squared is still 1, 4. We've already done 4 times 2 squared, which is 4 4s are 16. What about 4 times 5 squared? 100? Yep, 5 squareds are 25. So if I'm subbing my 5 in there, it's just 5 by 5 is 25. Remember, I don't do the 4 times 5 first, powers first. 4 25 is 100. The last one, it's just a little bit of algebra. I'm sure you could probably work it out, but let's just say, oh, you're making me go backwards. I know my formula is y equals 4x squared, but now you're telling me y is 400. Okay? And again, you could probably work it out from there, but the easiest thing to get rid of on the right at the moment isn't the squared, it's the 4. Okay? It's like undoing stuff, reverse BODMAS. Get rid of that 4. Subtract it or divide it? Divide it. It's timesing. I can't subtract that 4. If it was plus 4, but no, I've got to divide 4 from both sides. Divide 4, 100 equals x squared. Square root both sides. Now I know last semester we went on about the answers plus or minus. In these applied ones, we don't care about the minus answer. You're not going to be marked wrong for putting it, but we're doing distances, times, or we don't care about the negative answer, okay? We just care about the 10. Okay, so it's another predictable sort of thing. Here's a setup. If you can find the k, if you've got one set of complete values, yep, and then just use that for the other ones. Here's another one. It's just got a root x in there, but it's exactly the same sort of question. Find k. Well, the way we find k is by subbing in a complete set of data, and the only complete set of data I've got is that XY combo. So I'm going to chuck them into my formula. The Y is a 12 equals K times a root 1. What's root 1? 1. 12 equals K by 1. K by 1 is just K. Divide both sides by 1 if you want. It's still just going to say K is 12. So my formula is actually Y equals 12 root X. So again, just plug in. This says, what about when X equals 0? I'll chuck it in. When X equals 4, I'll chuck it in. What about when Y equals 36? Oh, I'll do a bit of algebra to be careful. What about when X equals 0? What's 12 root 0? 0. Root 0 is 0. 12 root 0 is 12 noughts. What about 12 root 4? It's 24 because root 4 is 2. Remember, I've always got the calc as backup, but it's saying what times by itself to give 4? 2 does. 12 times 2. And this one, I'll just do the algebra of it. Replace the Y. 36 equals 12 root X. Let's divide by 12. 3 equals root X. Root 3 would be a tempting answer, but what's the real answer? 9. Remember, don't get rid of a square root sign by square rooting. Get rid of a square root sign by squaring both sides. 3 squared 9 equals X. And look at this trend. I'm pretty happy with that answer. 0 was 0, 1 was 12, 4 was 24, 9 was 36, okay. Yep. But again, all I did there was I squared both sides. Root X became X, 3 squared became 9. Just a word test. What's the coefficient of probability for that function? It is just 1.8. So the coefficient of proportionality is just a number. It's not the cubing, it's not that. It's just the number. The coefficient of proportionality is just whatever some number is chucked in there. That's it. That's your K. That's the K we've just been finding. So here's the same sort of question, non-linear. Let's see how much does the non-linear stuff screw us up. What's the thing in there? What's the word in there that makes it non-linear? Cube. It doesn't say the mass of an egg is proportional to the length in centimetres. There is an extra word in there. That's the only thing that changes it from being linear. And all that does to me, instead of writing like y equals kx, that was linear, it's going to be cubed. That's it. But I've got to be careful. Is it the m that gets cubed or the l that gets cubed? L. It says the cube of its length. So my tactic here is I've seen the cube of its length, I've got myself an L cubed. Absolutely. Let's fill it out. So the mass is equal to something times L cubed. Okay? So don't accidentally cube the K, don't cube the M. It's said length cubed. There's some number in front of it, I'm calling it K, and there's a mass which has no cube, no square root, just that's it. My next step is just going to be, well, you must have given me some numbers I can chuck in. And it says a 6 centimetre long duck egg has a mass of 80. That's not a question, that's just giving me numbers. Let's sub them in. The L is 6 and the mass is 80. I don't care about the units, I'll look at them later. There's nothing wrong with centimetres and grams. So replace the mass with 80 and the length with 6. Go the calc, 6 cubed, well as a 216, 80 on 216. Okay, you could have left it as a fraction. I've written it to 3 decimal places. It doesn't matter what you want to do. Don't round it too much. Like, don't just call that 0.4. Your answer's going to get really messy. Really, I'm surprised I did that. I would have thought I would have left as fraction 4, but it makes no difference. Fraction or decimal. Okay? So we found the K, so we've got a formula. Already, that's it. The mass of each egg is equal to 0.370 times L cubed. So you give me an L, you give me a length of an egg, I'll work out the mass. Hopefully close. The question was, determine the mass of a hen egg, which is 4.5 centimetres in length. Okay, in other words, it's just saying L equals, let's check the units, 4.5 centimetres. Were our lengths in centimetres? Yeah, they were. Our formula was made using centimetres. So if we sub in centimetres, it'll give us a mass in grams. Everything's good, no conversions needed. So there's my 4.5 getting chucked in. I go to the calc and it tells me 33.7 grams, because that's what 0.370 times 1 length cubed is. Let's put our 10 minutes there. When? It's normally within about an hour of the finish. Sometimes, for some reason, it takes a couple of hours, but...
I've just got to head off now.
Yep.
See you later.
Yeah. If so, I just, no one did general, but... Was it in the middle? Yeah, no, it'll be around the front. Yeah. Yeah. Not losing it yet. Not losing the clock. It does.
How was it?
That's alright. Yeah. It's a bit dry. Nothing too exciting in that.
No. I'm going to shake your hand. I like that. Yeah.
Okay. Alright.
Yeah.
Are you still in the private stall thing or the fancy next week as well?
Yep.
All week.
All rest of the season, I'm probably not. Wouldn't surprise me.
Actually, there was 2 weeks there before I stopped. In the store you used to work in, the old lady,
Yeah.
she's still there. There was Hayden,
Oh, yeah.
and 282. Just as on your license.
Oh, I know who you're talking about, though.
Crucial.
Yeah.
Is this in math tutorial?
Math lecture.
Math lecture?
Yeah, for EPMATH127 Lecture A2. Applied maths. Or one after. No, it does maybe GP201.
Yeah, that's at this building.
Okay, well there's a GP201. It's a big altitude or a...
Yeah, the tutorial.
Yeah, I don't know. Most of the
Poke
tubes,
around.
there are tube classrooms that way, but also mostly on the second floor. The tube rooms all on this wall, I think, one or above. You're on the clinic picture. You're on the clinic picture. Are you on the day you're on the clinic picture?
My muscular calf.
Don't think so.
Should I put it at the end?
My
No,
calf's
I wouldn't have
over the back.
Oh, okay, no, it was the previous one. No, you're not in that one, it was the previous one I had. Yeah, okay. No.
No.
Let's put it at the end.
So when's the maths drop-ins?
Still every day at 12.
Oh, yeah.
Today we've got an extra one at 1, but normally just every day at 12.
Yeah, because I'll probably end up dropping in eventually for the help for the Stat 170
Yep,
at some point.
yep.
Anyway, I better get going.
Alright, later.
Get some food. I'll see you later.
See ya. Okay, another example, which is just another non-linear one. Everyone, please. Back to it. Okay, so what's the only thing in here which makes it non-linear? Keyword somewhere. Square root, that's it. And again, it's an easy trap. Separate your squares and your square roots. Happened last semester too. As soon as you see it, a lot of people see square root and go immediately, that's right, it's squared. But remember, it's not. It's square rooted. So let's check. The distance, again, the wording can get confusing. I'll try and keep any example and quiz ones just nicer, okay? We're not going for a trap because of the wording. The distance of the visible horizon D in kilometres at sea varies as the square root of the height of the observer's eye above sea level, h in metres. In all of that, I'm seeing it's a D and it's an h. There's a square root of the height, not root D, root h. That's all it says about the variables. And clearly it's a proportionality problem. D equals k root h. Okay? And I'll admit to you, even if you wrote, and I won't do it this way, even if you wrote root h equals kd, I'm just going to stick with whatever order it came in the question and write it that way. But that's still totally correct. It'll give a different k value, but it'll still work. It doesn't matter. But I'm just going to stick with the order. And what mattered, that I put in an h for height and it was square rooted. The d had nothing done to it. D equals k root h. So there's my d equals k root h. The question's always just going to have some numbers I can chuck in there. if the visible horizon is 10 kilometres away, so the d in kilometres is 10, when the eye, or the height of the eye level, is 5.5 metres. So again, this thing, it's got one thing's in kilometres and one thing's in metres, and traditionally we'll say, oh, you better convert them both. Again, it doesn't matter. You can use whatever units you want, as long as you're consistent. If you make a K with units where the H is in M and the D is in kilometres, that's fine. You can convert them if you want, you'll still be right. You're just wasting time. Okay? So it tells us that when D was equal to 10 kilometres, that the height is 5.5 metres. And again, I'm saying I'm totally cool with those units. But I know that any D I talk about is kilometres, any H is metres. There's my 10 going into the D, there's my H going into the 5.5. I could go to the calculator with that, but I'm just going to say if it's timesing by this, what's the opposite of timesing by root 5.5? It's dividing by root 5.5. It's just to save mucking around the calculator. There's nothing wrong with bringing that whole thing down in one go. Times by a number, the opposite is divide by the same number. So all that can go to the calc at the one time. Okay, so you've got a 10 divided by root 5.5, which comes out at 4.26. As for how many decimal places to do it to, that's about right. You just write whatever you did. The question's not going to tell you what to do in the middle. Again, don't just call it the number 4. I'll admit, you wouldn't get marked wrong. Okay? But just give it maybe 3 significant figures. You know, like, keep some digits. Don't just round off to the first one. So K equals 4.6, so we've got ourselves a formula. D equals 4.26 root H. The only thing I'm noting is that, remember, my D was in kilometres and my H was in metres. Rightio. Whatever question, what's the question? How far can a person see at a height of 12 metres? In other words, when H is 12, what's D? Well, I'll just sub an H of 12 in. 12 metres, that's correct, and this distance is going to be in kilometres. The calculator spits that out. Distance of 14.8 k's. And true, some people from that someone might have written 4.3. That's okay. And you might have gotten 14.6 because there's a little bit of an error. You're still both totally correct. Okay? That's going to happen this semester. Sometimes you'll get two seemingly different answers. They're just really close. Well, it just depends what you did here. Some people might have used the exact calculator method. It's just not critical. Okay? It's about close to 15 kilometres. That's enough. Another wordy one. Okay? Because that's the setup and it's the questions, it's everything. But again, this is not over the top. This question is actually pretty common. The braking distance is the distance a car continues to travel after fully applying its brakes. So you slam the brakes on, cars don't stop right there. Clearly it's screwed just for a bit. And the faster you're going when you're slam the brakes on, the further you'll still skid. Okay. So the braking distance is proportional to the square of the car's speed. So that's just the relationship. That's a real life relationship. Because of any, let's not go there. Because as the car's coming along, you'll see as on telly it says, look, this extra 10 k's in your speed actually increases your stopping distance by much more. Well, this is an example of that. So, the braking distance is proportional to the square of the car's speed. So D is proportional to, in other words, it's equal to K times something. I hope that looks right from that. It said the square of the car's speed, S squared. D equals, because there's nothing over the distance. That's the formula it wants you to know. Then it goes on to say, okay, we're talking about on a wet surface, fine. A car travelling at 80 kilometres per hour covered 90 metres before stopping. I'm not converting anything, but it's just saying the distances I'm using are in metres and the speeds I'm using are in k's per hour. Fine, let's sub in the numbers. A car travelling at 90 metres before stopping. There's my stopping distance, 90. K, I don't know what the K is yet. And the speed is 80. Okay, I've grabbed the right numbers. Distance 90, speed 80. Fantastic. Then, well, it's your call whether you want to put the 80 squared in the calculator yet or bring it all under. I'll just keep it simple and say, well, 8 8s are 64, and there must be 2 zeros. Hence, to get the k by itself, I better divide by 6,400. So my k is equal to 90 on 6,400, the same as 9 divided by 640, which is, no, don't set the time, oh, I've screwed it up already. 9 divided by 640 equals, oh, that's a plus. Can't read it. Has anyone got a calc near him? Sorry, say it again.
0.01.
Did it work out exact?
0.014.
4. And then there's more, or just, was what followed the 4?
0.
Okay, that's fine then. 0.014 was followed by 0, so I'm not rounding the 4 up. So I've just done that to 3dp. That number will do me fine, and that tells me my formula is distance equals 0.014 s squared. I just chucked the k in, I found the k. So that's the formula, done. Hope you see it's exactly the same as every other procedure I've done. Work it out from the words, chuck the numbers in, find a k, got a formula. What was the question? What would be the braking distance, rounded to the nearest metre, of a car travelling at 70 k's per hour on the same surface? So we knew it took 90 metres to stop at 80 k's per hour. How much less will it take to stop at 70 k's per hour? Well, let's just chuck it in. The distance it'll take to stop will be 0.014 times the speed squared. In other words, I just used my formula and chucked in a 70 squared. The chat in the middle, can we please nod? It's just all putting. Has anyone still got a calc happening for that? 68.9. So it said the nearest metre, so round to 68.9, 69 metres. Okay, so instead of being 90 metres, 10 k's off the speed, brought it down to 69 metres. It's not actually a safety message, it's just, okay, fine. It's the truth. Okay. Yeah. That's this at the moment. So let's move on. I'll just let you get that. I think now to the inverse. Okay, so inverse is the odd one out, no doubt. When one goes up, the other goes down. Okay, it's odd, but it's real life. And the way we do it doesn't change much, okay? It's still pretty much the same setup, but we're definitely looking for a key word. If the question says inverse, okay, I've got to notice. So, we say it's inversely proportional if an increase in one variable makes a decrease in the other. Fine. There's an example. When x is whatever x and y are, when x went from 1 to 2, the y went from 1 down to a half. So in other words, the x got doubled, the y halved. You can see between that point and that point, when this x got tripled, the other one got a thirded. So there was just an up-down association. So applied examples. Well, again, we don't have to know that the sketch looks like that. I hope it makes sense that, okay, let's look. Cost of a gift. We're putting together for $100 for someone's present. So cost of a gift, there's 100. If only one person is contributing, they're going to have to pay $100. What if 2 people are contributing? Maybe that point says 2 goes with a 50. If it's 2 people, it's only $50 each. What if 3 people are contributing? Well, now it's down at $33 each. So you can see, and so on and so on. That's why it looks like that. Again, not that we have to know. But yeah, it plots all these points that relate. What about time of journey and average speed? That just means, again, not a safety message, the faster you go, the quicker you'll get there, given limitations, okay? But yeah, I can pick any point on that curve. If my speed is high, my time of journey is low. If my speed is low, my time of journey is high. Inversely proportional. Another one, time to finish task versus number of workers. Again, there's limits. Like, if there's one person here doing a task, could take ages. If we were all working on the task, maybe with lots of workers, it'll take less time. But it's true that, maybe there'll be too many workers and, we back to suffocate and all that and can't even move. So these are just simplified things. Okay. Other words used, any of these inverse ones, again, I'm going to be consistent. Inversely proportional, that's it. Indirect. If you're looking for questions elsewhere and it says they're indirectly proportional, it's the same thing. I'm not going to use it, but it's the same thing. Varies inversely or inverse proportional. It's a clear thing. Just look for inverse. So what does that do? This is the different thing. Okay? The first thing we did was linear, and all we did was say y equals kx. That was nice and straightforward. Then we did non-linear, which all it had was maybe a square root or a squared or some other function happened to it. Every time you see an inverse, what happens is the k stays here, the variable goes to the bottom. End of story every single time. Okay? That's how you graph these. Y equals k on x. As a bit of a side proof to that, let's go back to the $100 present. If the cost per person, cost PP, is equal to some constant, which in this case would be 100 over the number of people. What I'm saying is, if we had one person, the cost per person would be 100 on 1, which is $100. That's true. If you had 2 people, it would be 100 on 2, which is 50. If you had 3 people, it would be 100 on 3, and so on. The variable goes to the bottom. The whole inverse thing basically means I'm upside down. Okay? So if we lock in that the variable goes there, the k is still just on top, but the variable goes to the bottom. Even if it says varies inversely to the square of x, it says square of x, x squared, it's still on the bottom. Again, nothing else gets squared. It said x got squared. Okay, x got squared. Cube of x, x got cubed. So all of these are exactly the same as the previous slide. It's just this x stuff is on the bottom, not the top. Inverse did that. Okay. When a car is required to cover a distance of 100 kilometres, the time varies inversely to the velocity or the speed. That's what we were saying before. The time of the journey varies inversely to the speed. So this is just an example. So if I'm travelling at 100 kilometres per hour, my 100 kilometre journey takes an hour. If I'm travelling at 50 k's per hour, it'll have to take me 2 hours. As my speed goes down, my time taken goes up. And that was just my justification again. Why does it look like that? Just plot the points. 100 goes with 1, 50 goes with 2. It might seem odd that it's curved, but you can see it is. It's not a straight line. There's not a straight line that goes through here and says, well, if you travel at this speed, oh no, what's the thing? It will take 0 time if you travel at this velocity. Well, that's not going to happen. There's no velocity at which it's going to take 0 time. These things aren't curved. For something I said it doesn't matter, I'm spending a lot of time on it. But I promise it doesn't matter if you know what it looks like. This is what matters. And again, this question, it's a nice one to start with, just because you could do this through common sense. And if you did this through common sense, if the question just said, oi, answer it, fine. But the question will say, write an equation involving the coefficient of proportionality. Make a formula, make an equation and then use it. So let's go for it exactly. The rent per person in a share house varies inversely with the number of people living in the house. If 5 people live in the house and pay $65 per week rent, find an equation for the rent per person. How much would each person pay? And then the question we'll come back to. So the rent per person varies to the number of people. So let's call it rent per person. I'll call you R. And the number of people living in the house, I'll call you N. So it's an equation between an R and an N. And it says inversely. No squared, no square root, nothing else, just inversely. So if the word inversely wasn't there, I would have said that. Just straightforward. But the word inversely was there. All it does is put the variable on the bottom. What if you wrote it the other way around? It may not look like it, but it's exactly the same thing. It doesn't matter which variable you put on the bottom. It's still the same thing. Because that formula, R equals K on N, if I times both sides by N, becomes Rn equals K. If I divide both sides by R, becomes N equals K on R. They're the same formula. But as of every example, I'm just going with the first thing that happens. Oh good, I did the same thing. R equals K on N. Yep. Then it must have given me some numbers to chuck in. It said when N is 5 people, rent is $65, chuck it in. 65 equals K on N. So if 65 equals K on 5, I times by 5, that's a divide by 5. If I want to get rid of divide by 5, I'll times by 5. So K equals 65 by 5. What's the 325 mean in real life? It's the total rent. So you can still see your common sense thing here. If it's 5 people paying that, obviously that is just the total rent, and I'll divide that by the new number. Okay? But answering this question the way it says is, yep, we've found the formula. We found the K. Rent is 325 divided by how many people you've got. The question then said, what if there was only 4 people? Clearly, number of people go down, rent goes up. If it's 4, 325 on 4, there it is. $81.25 new rent. Okay, so that was just the introduction of the word inverse. Chuck the variables to the bottom. Stop it, that picture. Now this one. Remember saying last semester, even though I know these are 2 separate courses, that candela is some unit that's used in the SI units, but we won't use it. This is saying that we don't have to understand what it is. Intensity of light, it's talking about brightness, and it's measured in candelas. We're not physics, okay? But we just know when we're making these formulas, whatever units you put in is the same as you get out, so I don't have to understand it. The intensity of light, I, varies inversely, which tells me, well, the other one's going underneath, with the square of the distance from the light source. What completes this? D squared. Okay, so chuck 2 things. The word squared of D and the word inverse. Inverse says, down it goes, the square of the distance. Okay, that's my formula. And as you've probably seen, once you've got the initial formula, the rest just flows on with a bit of algebra. It then gives me some numbers. At a distance of 4 metres, in other words, when D equals 4, the intensity is 188 candela. I don't care about the units. I is 188, D is 4. Don't forget the formula said to square the D. So I've got 188 equals K on 16. So in order to get that K by itself, I've got to times both sides by 16. So K, I'll leave it on that side, 188 by 16 equals K, and K equals, I don't want to, anyone? 3008, beautiful, So the formula, stop it, 3008, okay. There's my formula, there's the number, I equals 3008. For some reason, people then don't write the squared. It's still there. No one undid that. The original formula had it, D was squared, it still is. All we did was find the K. So just combine the 2. So intensity is 3008 divided by D squared. You give me any distance in metres, I will spit out a I in intensity in candelas. So at 2 metres, well I know if it was 188 candela at 4 metres, it's going to be a lot brighter at 2 metres because they're inverse. One goes up, one goes down. Let's just do it. Let D equals 2 metres. My intensity now is 3008 divided by 2 squared. Okay, so 3008. We're dividing by a 4. Anyone? Ta. And I'm going to write candelas, whether I understand it or not. That was the units, 752 candelas. Okay? So it's brighter the closer you got. Yeah, that makes sense. Shorten the distance, up the brightness. Okay, that's the last of our wordy ones, I think. Now we've just got some things we did before was, what if you were just given a table? Well, we're given a table, we're given a rough formula. What's the first thing I want to try and do to solve this, to find the blanks? Find the K. What's my best way to find the K, or only really? 2 and 9. Now, no, just say hypothetically, This number was filled in, this number was filled in, and this number was filled in. And I wanted to find the k. Which point should I use? Whatever you want. Okay? It doesn't matter. There's lots of points. Except for the 0, 0. Never plug in the 0, 0 because that's not going to work for us. But all these others, if I had options, it wouldn't matter which one I picked, I'll get the same answer. But I don't have options. I've only got the x equals 2, y equals 9 to go with. The y equals 9, so replace that. K over x squared. X cubed, sorry, it says. So that's just subbing in a y equals 9 and x equals 2. 2 by 2 by 2 is an 8. And how do I get rid of a divide by 8? I times by 8. 9, 8, 72. Okay, my formula is y equals a k of 72 divided by x cubed. Okay, just chucked it in and solved it. And now, if we were to use that, if that x was a 1, what's 72 on 1 cubed? It's just 72 on 1. 1 cubed is 1, 1 by 1 by 1. So 72 on 1, yep. What if x was 3? That would be 72 on 3 cubes. 3 by 3 is 9 by 3 is 27. So 72 on 27, what's that, about 2.5-ish? 2.6, repeater?
Yeah.
Sweet, so that's fine. And again there, if you wrote 2.7 to 1 dp, because remember it's followed by 6 so it rounds up. 2.6 repeater, just write it like that. It's way too easy. And the other one, okay, that looks a bit podgy. Okay, so we've got, let's just sub in. If y is a third, that's me chucking in everything. Now, if I wanted that x cubed not to be on the bottom, I can still times both sides by x cubed. If I times the right by x cubed, it disappears. If I times the left by x cubed, it goes to the top there. Because if I'm timesing by, think of it as an x cubed on 1. What was I really doing there? I was timesing it by x cubed on 1. So only the top cop's the x cubed. I can get rid of that 3 by timesing both sides by 3. And how do I get rid of a cube? I've got to find me cube root key. Opposite of cubed is cube root, and the cube root of 216 will be 6. So as x went up, y went down. So that was a much nastier algebra-wise. You could also have maybe checked a few things to see what it was going to be. And then the last one, is there a last one? Okay, just that one. And this is a hint for multiple choice. One of them, this can be answered without doing it, which seems odd. Why can that be answered without even doing the question? Why does only one answer make sense? Well, if it's inverse, if x goes up to 90 and they're inversely proportional, what will 60 do? Yeah, x has gone 30 to 60, it's doubled, the y has gone lower. The answer's got to be less than 90 if they're inversely. Even without working out, it's got to be the 45. Just a speed hint, if it's inversely and you know the concept, one goes up, the other goes down, 90 had to go down. Anyway, done. Don't forget, if you wish, there is a Monday clinic. Now, or soon. Sorry? I got rid of functions. Actually, I'll send you an email. If you're using the old book, I'll send you an email. Okay. Hey. Yep. So yeah, it's okay. You just got to do the question. You know, the subway. We were doing the subway. The whole. Yep. So if you go down the right-hand side of it, okay. So the right-hand side of it, you just see a bridge. Yep. Yep, it's just that bridge. Just cross it, and you'll just run into it. You'll go past this chance, and you'll see the signs. The 100 building is something, but it's the only big thing over there, and you'll run into it.
Thanks, Dave.
No worries. Cheers, Dave. No problem at all. Keep down, save. How's things going? Yeah. Yeah, it's just here. Yep.
Did I miss much last week, or was it just lecture 1?
It was lecture A1, the recording's there, there was no quiz last week, but there is this week,
So just
yeah, just on A1. Yep. And they're all calculated quizzes now, and resource sheet. Yep. Cool.
That guy annoy you when he plays for Queensland?
Oh, yeah, and he plays so much better for him too,
Yeah, that's right.
which that does annoy me, and I'm going to hate to see him playing for South next year. That's,
You hate to go.
well, yeah, once a night, always a night. I don't like seeing Knights play for anyone else. I still hate watching.
But he still stabs him in the back. Well, not really, I guess, because he's from Queensland.
Yeah, exactly. So it's just a dumb thing.
But he does play better for him.
He does. Yeah.
I think he should put a more stake there, I guess.
Yeah, I suppose everyone plays better for that, but
Yeah.
not as. It's really different. Anyway.
It's like he just couldn't be bothered, just drops along.
Yeah. It's annoying. Anyway. That.
I want to make a nice joke, but it sounds like it's a sore spot for you too, so I'll just, relax.
What's a sore spot for me? A nice joke. Why? Because they won. You can't make any nice jokes this week. No, not this week.
Not this week,
you
but
can't-
every other one.
Half the teams lost this weekend. Not the Knights. We're in the top half.
Yeah, it changed it.
Are you going to the drop-in now?
No, I'll get some stuff done, but I'll be there at 1. Oh, actually. Oh, I might. Actually, no, I will. Yes.
And then I'll see you in a bit.
Got a drawing class.
Oh, cool. Wait, is that 191, 192, one of them?
Not
The design drawing?
society.
Okay, yep.
Is that computer? I don't know, because I had to switch from media to that because it was clashing with this.
Okay.
Is it computer or camera? Graphic design.
I know one of them is computer, but I don't know which one's which. Yeah.